Okay, this is lesson 2-1. Now, chapter 2 is all about relations and functions. Relations and functions. Now, it's a very big part of your EOI. So, our goal today is analyze relations and functions and use equations of relations and functions. All right, Pascal, you can see this is all part of Pascal 2-1, and you can see right here, all this stuff right here has to do with functions and relations. All right, first thing we talk about here are the basic types of functions. You have a one-to-one function. You have an onto function, and you have ones that are both one-to-one and onto. All right, one-to-one function. Basically, it's like this. These are your domain numbers right here, and every element of your domain goes to one and only one element of your range. All right, so you can see how 1 goes to D and 2 goes to B and so on. That's called one-to-one. An onto function, you may have two things from the domain going to the same thing over here. All right? That's all right. It's just a different type of function. It's called an onto function. Okay? And then a lot of times you'll have functions that are both one-to-one and onto. Okay? All right. Questions? Don't worry. I'll help you with this. All right, so the first part of your lesson here, we're going to state the domain, we're going to state the range, we're going to state whether it's a function, and if it is a function, one-to-one, onto, both, or neither. All right? Okay, first of all, domain. When you're thinking domain, think x. X variable is your domain variable. Range would then be y. The easiest way to remember this is domain and range are two words that are in alphabetical order, okay? You got domain, you got range. X and Y, those two letters are alphabetical. So X goes for domain, Y goes for range. All right? So when you're putting in your domain and range, you're trying to figure it out. Domain, right here, put it in set notation and just list the numbers in order. All right? 5, 10, and 15. Simple enough. Range, just list them in order. 105, 110. Shouldn't be any questions there. We all okay? All right, now, if by some chance a number shows up more than once, such as in this one right here, we would just go through and we would list one and one time only. So, for example, -2, I'd only list once. I wouldn't list it twice. All right? Okay, now, that takes care of listing domain and range. Determine whether each relation is a function. But what we have up here is called a mapping. All right? This thing right up there is called a mapping. Mappings are real easy to see if something's a function. Basically, you're looking for this. Take a look at your 5 there. If 5 mapped not only to 105, but also to 110, then that would not be a function. Okay? Notice you're looking at a branch right here. If x branches, it's not a function. Now, on the other hand, they can both, for example, they can cross over like this, or they can go and do something like this. 2 can go to the same one. That's all right, as long as you don't have something like that happening. All right, if that happens, it's not a function. All right, so this is a function for this this one right here. All right, that's a function. Now, what kind of function? Well, look at this. Do you have any two numbers in your domain that go to the same thing over there? Yes, and that's called an onto function. You have two domains going onto the same range. Make sense? Two domains going onto the same range. And that takes care of that example right there. Let's take a look here at this next one. Go down just a little bit. All right, this is a chart, XY chart. You've used those a lot. Easiest way to tell if it's a function is just build a mapping like we had in the previous example. X, Y, domain, range, -2, -1, 1, 2, -1, 0, and 1. All right, now for your mapping, you'll notice that -2 goes to -1. -2 goes to 1. Anybody see a problem with that? Okay, so that's not a function. We can stop right there. All you need to do with this domain, the range, say it's not a function. If it's not a function, it can't be on or one, all that other stuff. It's not a function, it's not a function. All right, now another way that we can represent a function is by a graph. Here we've got a set of points. Easy, the domain is which numbers? X. So when they ask for the domain, you list out the X numbers. The range is Y. All right, so you list out the Y numbers. Okay, determine whether the relation is a function. Anybody ever heard of the vertical line test? The vertical line test. All right, it's a test to see if something is a function. You take a vertical line, such as this. Tell me when it's straight. Is that good? All right. You take that vertical line like that, and you slide it across the function. If it touches more than one part of the function or one part of the graph, it is not a function. Stop grabbing the graph. There you go. All right. It's kind of dragging both of them, isn't it? Stop. There we go. Get it there. There we go. Does it ever touch more than one dot at a time? No, that's a function. Okay? Now, to determine if it's one-to-one, onto, both, or neither, the first we look at is onto. Okay? Onto. Take this little line right here and do like this. Make it vertical, or make it horizontal. Does it ever get onto more than one point? That's onto right there. Okay? Simple enough? You can tell that by looking. You don't really need the horizontal line on there, but that's what you got there. Anybody got questions on that? Everybody good? Okay, we're going to pause the video for a second then. Continue. All right. Now, when you're dealing with functions, there's two types of functions, especially ones that are graphed. You've got discrete functions, you've got continuous relations, or discrete relations and continuous relations, rather, not functions. Discrete means there's gaps in it. Okay? It's not a continuous thing. I mean, just think about what the words are saying. Continuous is like this line right there. It's continuous. If you have some... Stop. If you have something like this, that's continuous. All right? If, on the other hand, I had something like this, that'd be discrete. Okay? It's got gaps. Simple enough? Discrete versus continuous. All right. And we talked about the vertical line test, correct? All right, so now then we'll look at a graph and talk about that for a second. All right, y equals mx plus b. What does that mean? It means slope and intercept. Okay, so the slope on this equation that we're looking at right here, what is m? Okay, 3. Think of that as 3 over 1. What is b? -1. Okay, start with b. Graph it. -1, your y-intercept. Build your slope. Up 3 over 1. 1, 2, 3, up 1. 1, 2, 3, up 1. 1, 2, 3, and just keep doing that. As many as you need to get that thing. And then we'll graph the line. Take this one. That looks like it right there. Uh-oh. Touched. Okay. This out of the way. So higher. Okay, there's your line. Okay, let's answer a few questions now. Determine whether the equation is a function. Is that line a function?
Yes.
Yes. Okay. Is it one-to-one, onto, both, or neither? Okay, it's one-to-one. It's not onto, correct? All right. In this case, it's both. All right? Because they have to have the same amount of things going in the domain as the range. Each domain has a specific range. All right? So lines are usually going to be both. And is it discrete or continuous? Continuous. It's not discrete. It has no gaps in it. No buts about it, son. All right. Now let's take a look at this one. All right, graphing these points. I got -5 goes to 2. 1, 2, 3, 4, 5 goes to 2. Okay, 4 goes to -2. 1, 2, 3, 4 to -2. All right, 3 goes to -11. 3 goes to -11. It's right about there. And -7 goes to 2. Is that a function? Does it pass your vertical line test? Yeah, it does pass your vertical line test. That's a couple extra vertical lines, but hey, you really just need one vertical line for the vertical line test. You don't really need two. So yeah, it does pass the vertical line test, okay? All right. Next thing, the domain, you've got that. You've got the range you get. Is it 1-to-1, onto, both, or neither?
Onto.
It's onto. Good. Discrete or continuous?
Discrete.
Perfect. Discrete. All right. Okay, now, do you recall middle school when you were learning about graphing?
Yep.
They made you build charts such as this. Okay. What number could you put in for x?
1, 2, 3, 4.
1, 2, 3, 4. What number could you put in for x? Any number. Any number you choose. Okay? That's because x is an independent variable. Doesn't matter what you put in there for x. Okay? But once you selected your numbers for x, what did you do with those? Put them through the equation. Remember that?
Okay.
Plug them in, exactly. And then you got a y number. Y's value depended on what x was. That's why y is the dependent variable. X is your independent variable because it doesn't matter what you choose. Y is dependent because it depends on what x is. All right? So that's that, and we talked about that, and let's move on. Okay. Oh, I almost forgot function notation. How could I do such a thing? We just got through graphing a problem, and I believe it looked like this. Didn't it? Okay, that was a function. When you have something that's a function, you can put it into function notation. Function notation for this equation would look just like this. F of x equals 3x minus 1. F of x just takes the place of y. So anytime that you see f of x, I want you to think y. Not why am I seeing f of x, but this is y. All right, so f of x and y, interchangeable. It's all good. If you see f of x, you don't have to do anything else. It's a function because it's in function notation. All right, so if I were to ask you, is this a function, you would say,
No.
you would say yes because it's in function notation. All right? Okay, and then what you do with function notation, same kind of stuff we did last week when I told you, this is x, try these numbers in for x and put them in there. For example, if f of x equals 5 over x plus 2, I want to evaluate f of negative 4. So f of negative 4 would equal 5 over negative 4 plus 2. Now, with your calculators, I want you to open up a brand new screen on here. Okay. All right, so you'll go to the home screen. I'll say, we'll add a page there. How's that? There we go. New computer page. We will go to the home screen. We will pull up the correct display. Now we'll go to the home screen. There. All right. We're going to pick the calculator, and we're going to put that problem in just exactly as it looked. Okay, 5 over negative 4 plus 2. Don't forget to use your parentheses. 5, and remember, you can do a fraction by control and divide. 5 on top, negative 4 in parentheses. What was it, plus 2? Plus 2. And when you push enter, you're going to get the right answer. All right? It's not, I mean, you don't really need a calculator for this one, honestly, guys. I mean, negative 4 plus 2. What is negative 4 plus 2? Yes, it's negative 2, right? So you really have 5 over negative 2. But the calculators are really good for for the very difficult type problems. Okay. On this next one, I'm going to be using my g function because they tell us to use the g function. So g of 1/2 is negative 2 times 1/2 plus 3. Calculator or brain on this one? Brain. What's half of negative 2? Negative 1 plus 3. Negative 2. All right.
It's 2. 3 is
Oh, good. You're paying attention. I was making sure that you were paying attention. Sometimes we need to do that to make sure that you're paying attention. Questions? Your brain is more powerful than the calculator. The calculator is going to do the exact math problem you tell it to do. If you accidentally push a wrong button, it's going to do the wrong problem. All right? So a very simple one like this, your brain won't make mistakes if you train it correctly. Okay. Back to the video. Here we go. All right. Your calculator won't do this type of problem, though. Your calculator does not understand what the variable b is worth. Okay, because it's a variable, it has really no value until it's been assigned a value. So if we try to put this into our calculator, where I've got f of 2b equals negative 2 times 2b plus 4. And although this is a very simple little problem, if we try to tell the calculator to do it, it won't understand it. So we just have to be able to do this one. All right, so just like we learned in the last chapter, what is negative 2 times 2b?
4b.
Okay, and then plus 4. All of our like terms are gone. All of our parentheses are gone. That's a simplified expression. Questions? Okay. Here we go. I'm going to finish this up now. Okay, for those of you at home, here's your assignment. You can pause this as I scroll through, and you can do it on your own paper. And that way, if you're absent on Thursday, you can do it and have it ready to turn in on Friday when you get here tomorrow. So there you go. Everything else was in the lesson. That's